implicit differentiation. Okay, so we're looking at implicit. These are all non-functions that we're looking at, okay? So far, up to today, we've only looked at what's called explicit. Explicit usually have f of x equals, or y equals, right? The function can be expressed as an equation in terms of one variable. I know there's two variables, but one of them is isolated, right? That's explicit, okay? Today, we're going to look at non-functions, okay? Those are mostly functions. So implicit is when the function is implied by an equation, when we can't solve for y. We can solve for x. I can solve for x here, but I can't solve for y because there's too many y's. How do you isolate something when there's two of them, right? So a lot of x equals. There's a lot of x equals things, right? So what's the difference? Well, if you were to graph explicit and implicit, I have a little example, okay? Explicit functions, these are what they look like, right? Linear, quadratic, this is, I think, cubic, right? That's what we're used to. In Math 1, Math 2, and Math 3, we only look at these guys. Non-functions, we really don't look at, except in calculus, okay? You're never going to have to graph them. That's the thing. You're never going to have to graph them. The only reason I'm showing you this is because what do they look like? How are they different? Well, you can kind of see with your eyes, right? They don't pass the vertical line test. If we want to know if it's a function or not, we usually use the vertical line test, right? All of these guys, if I go from left to right with my pencil, right, it only hits the graph at one spot, right? They're functions. These guys fail, right? These guys fail big time, right? I'm hitting twice, 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 right? So they're non-functions. So that's what they look like. If you're interested in what they look like, implicit looks like that, okay? So that's the difference between the two, okay? Like I said, you're never going to have to worry about what the graph looks like, but if you're just curious, that's why I didn't put it on the notes. That's why I didn't put it on the notes, okay? Okay, so here we go. When we're doing this, even though they're non-functions, we use the same rules. Power, product, quotient, chain. There's no rules that I haven't shown you. I've shown you all the rules for derivatives. They're just some modifications. They're slightly different. They look different because they're different functions. They're non-functions. Okay, so what exactly does dy over dx mean exactly? So there should only be one exactly, obviously. So you can cross one out if you want to. It's just excusing the bad grammar. What does the dy over dx? You see it a lot. You see it on every notes I've given you, every assignment I've given you, the tests, the quizzes, dy over dx. And we talked about it, but it's been a while, right? So the dy over dx, why is it a fraction? Because derivatives are slopes, right? What are the two parts of a slope? Rise over run, right? That's why it's a fraction. So what does the dy over dx mean? It means the top is the derivative of y, dy, derivative of y, because the function always says y equals, or f of x equals, right? The bottom is with respect, sorry, it should be x. I don't know why it says y. With respect to x, this should be an x. Okay, should be with respect to x. I don't know why I wrote that in, but yeah. Okay, so that's what that means. When you see that, that's what that means. Cross that out. Okay? Okay, so when we found the derivative of equations, such as we did, what the heck does that mean? When we found the derivative of equations such as we did wow. Wow. When we found the derivative of equations such as, I think I meant,
You put the y equals.
yeah. Okay, I don't know what I meant. But anyway, we did the following process, okay? So let's look at, wow. What the heck?
Y equals 3x squared.
Does you guys have something on there? Yeah, you guys have something on there. I don't. That's why. That's why.
Yeah, just the
What the heck did I do? I think
Oh, what is the explicit?
Yeah. So let me see. I have it up here. Let me. Sorry, that's why it's not making any sense. Yeah.
When you find the such as we did, that's grammar.
Yeah, sometimes I'm not good with the grammar, but that's just like, I knew that wasn't that bad. Okay, such as, here we go. Y equals 3x squared. You guys already have this on theirs. Minus x minus 2. Okay, we just spent a whole chapter, whole unit doing how to find derivative of that, right? Plus 2? Thank you. Okay. Okay, so how did we find derivative of this, right? What did we use to find derivative of this? Which rule did we use? Just the power, right? Just the power. We didn't need to use any of the other rules. Okay, so I'm going to solve it, but a different way. Not a different way, but just omitting some things that we did in the first. So dy over dx. Why does this come? So when I'm doing the derivative, why does y change into dy over dx? With respect to x, right? That's why it became that, right? It's the derivative of y with respect to x. And then we did the derivative of 3x squared, right?
Yeah.
That's 6x. What did we just find derivative of?
3x squared.
X or y? Okay. So really, we just found derivative of x. So really what we were supposed to do is state that. We just found derivative of x, right? So we would say that's the derivative of x with respect to x. But we never wrote that down, right? And so let's keep it going. Let's keep it going. Minus, what would the derivative be of negative x? Negative 1, right? I just found the derivative of x, right? So I would say dx for derivative of x with respect to x. Now, nowhere in your notes, and that's it, right? Did you have dx over dx? Why not? Why didn't I include that last chapter, even though that's what we were doing? Not to confuse you, but look at what it is. What is dx over dx equal to? 1. It's just a 1, right? Why write it if it's not necessary, right? So instead, we just said dy over dx is 6x minus 1. So when we were finding derivatives of x, it wasn't necessary because it was just a 1, right? But now we're finding derivatives of y's. So we have to write it down because it's not dx over dx. It's going to be dy over dx. Okay, so let me write down the one you guys have. X squared minus 2y cubed plus 4y equals 2, right? So this one's implicit. How do we know it's implicit? Because we can't get y by itself. Anytime I can't get y by itself, it's going to be implicit. Okay? That's the best way to tell it. That's the best way to describe it. Okay, so let's find the derivative. Okay? What's the derivative of x squared?
2x.
I agree. Dx over dx, right? But I don't need to write it because it just equals 1. Okay? So now let's do the derivative of negative 2y cubed. What do you think the derivative of negative 2y cubed is? I bet you guys know. Keep going. There you go. It would be negative 6y squared. It's the same rule. It's the same exact rule. It doesn't matter if it's an x or a y, it's the same rule. The only added part is we got to put, what did we just find derivative of? Y. So we have to put a little tag. It's times dy over dx. All that tag is saying, that should say y. All that tag is saying is that, hey, I just found derivative of a y with respect to x. Okay? I didn't need it for x because it was I just found derivative of x. Okay, what do you think the derivative is going to be of 4y?
4.
But I just found derivative of y, right? So I need a little tag. dy over dx. Equal to 2. What's the derivative of 2? Do I need a dy over dx with a 0? didn't have a y. It didn't have a y. So you know you don't need that. Okay? There is another step afterwards, which we'll do on the next example, but I'm not worried about that step right now. The big thing is, why do we have dy over dx's? Because we're finding derivative of y's now, not just x's, of y's. Okay? All right, that's the big thing. If you can understand that, the rest of it is just going to be rules that we've done before. Okay? All right, so let's take a look at example number 1. Again, we know this is implicit because x's and y's are mingling together, and there is no way for me to isolate a y. Can't do it. There's y's there, y's there, y's there. Okay? I could isolate x. When it's easier to isolate x than it is y, it's implicit. Okay. All right, so let's find the derivative. So again, we have 1, 2, 3, 4 terms. 4 terms, and we need to find the derivative of each of them. Okay, so let's start with the green. What would the derivative be of negative 3y squared?
Minus what? Minus 6y.
Minus 6y just to the first power, right? And then it needs a tag, right? It needs a tag because it's a y. We just found the derivative of a y. Okay, let me color code that. Yeah. The yellow, what's the derivative of the yellow? Negative 1. Did we just find derivative of y? Yes, so it needs a tag, dy over dx. You can put a little dot in there for multiplication, or you don't have to. If you don't have, it's already assumed it's multiplication, but I just always put a dot there just to show. Okay, that's the yellow. Now magenta. What's the derivative of the magenta color? Fuchsia. 10x. Do I need a tag there? No, because it's derivative of x. No tag needed. Equals. What's the derivative of the orange? Negative 9y squared. Does this one need a tag? Yes, dy over dx. Okay, so your first step is to find the derivative. Find the derivative.
Yeah.
Okay, that's the derivative. Yep, it's right there. Okay, when we do this, step 2 is to isolate the dy over dx's. Now there's a bunch of them, so we got to get them all on the same side. So that's where my equal sign is. The blue line represents where the equal sign is, right? First thing I got to do is get all the dy and dx's on the same side. If it doesn't have a dy or dx, it needs to go to the other side. So I can gather them on the left side of the blue line or the right side of the blue line. Doesn't matter, right? I have 2 of them over here. The green and the yellow have dy over dx. The pink doesn't have one. The orange does, right? So I think what I'm going to do is I'm going to switch spots. I'm going to switch these guys. To do that, I have to do the opposite, right? To switch sides, to go on the other side of the equal sign, you got to do the opposite. So here I'm going to add 9y squared dy over dx to both sides. And then I'm going to subtract 10x from both sides. Okay. So positive 10x minus 10x, 0. Negative 9y squared, positive 9y squared, 0. Okay. So over here I have negative 6y dy over dx minus 1 dy over dx, and then now I have a 9y squared dy over dx. And then on the other side, I just have a negative 10x. Okay, this is all multiplication. They each have a dy over dx, right? Okay, so I can factor out a dy over dx. If all three terms have the same thing in common, right? They only have dy over dx in common. I can factor out a dy over dx. So dy over dx. So now there's no dy over dx's with negative 6y, so now it's negative 6y minus 1 plus 9y squared, because I factored it out. If you want to give them back, just do distributive property and you can give them back. But we want to isolate it. Okay, big question, how do we get dy over dx by itself now? What's the last step? Divide. Divide by, not dy over dx, because I want to keep it there.
Minus 6y.
Everything else. Divided by everything else.
That is in fact the formula.
So anything divided by itself just becomes a positive 1. So now I have dy over dx equals, so I got negative 10x over negative 6y minus 1 plus that. You're done. So that's how we find derivatives of implicit.
That's
Okay? So first thing, find the derivative. Find the derivative, then isolate all the dy and dx's. Okay? All right, let's take a look at another one right below it. Why is mine's all...
oh, that's why it's like a. Don't put the pre-roll.
My formatting's all off. I don't know why my formatting's off, but we'll go with it.
Bro, no room.
Yeah, I know. I don't know why. I don't know what happened. Okay. Okay. All right, so next one. Find the derivative. So let me write it up here. Negative xy squared plus x plus 4 minus equals 0. So we got to find the derivative. First thing.
6y's old thing was y get the exponent only. Like, does it become minus 2xy or does it just become minus x2y?
So for which one are we talking about?
The first one?
The first term.
Yeah. So what are we going to do with that? How do we find derivative of the first term?
Multiplication rule.
There you go. Multiplication product rule. Yep. Because it's x times y, we're going to need to use the
I'm asking the wrong questions.
product rule for that one. Okay? Remember, there's a negative 1 in front. There's a negative 1 in front there. So the product rule says the first, so negative 1x or negative x, times the derivative of the second. So what's the derivative of the second? There you go, 2y times dy over dx. Sometimes you'll see, so I've had some students do this. Instead of writing dy over dx, they use y prime. That's okay too. That's okay too. Some students prefer that because it's not as messy. That's okay. You know, so instead of that, instead they'll do this. They'll say y prime. Okay. That's okay too. I don't mind that. I use dy over dx just because that's the way I've done it forever and the way I was taught, but you can use y prime too. Okay? All right, plus the derivative of the first, which is negative 1, times the second. I don't need another dy over dx because I didn't find the derivative of y. That's the derivative. Plus, what's the derivative of x?
1.
Positive 1. Does that need a dy over dx? Nope, because it's wasn't a y. Then the next term is positive 4. What's the derivative of positive 4? 0. So I don't need to write that. Next thing is negative y cubed. So what's the derivative of a negative y cubed?
Negative 3y squared
There you go.
times
dy over dx or y prime. Okay.
No, don't like that.
Equals the derivative of 0 is just 0, so that stays 0.
I thought we were trying to make it constant. It is a constant. Hey, look at that.
Step 1 done.
It's on.
Get everything with the dy dx on one side of the equation. Give everything else on the other side of the equation. So I have two terms, I believe. This guy here has a dy dx,
Yes.
and this guy here has a dy dx. You could either move them to the other side or you could keep them there. It doesn't matter, okay? What I'm going to do is I'm going to keep these two here, move these two terms to the other side. Okay? So to do that, I need to do the opposite. So I got 1y squared and minus 1. 1y squared minus 1. So I got negative 1x, or just negative x, times 2y times dy over dx, minus 3y squared dy over dx, equals y squared minus 1. Okay. And I'm going to move over here because I'm running out of room. So I get negative x times 2y dy over dx minus 3y squared dy over dx equals y squared minus 1. So yeah, since I got my dy dx is on the same side, factor out a dy over dx. So we get negative x times 2y minus 3y squared. And then y squared minus 1. Last step. What are we going to do? What did we do? What was our last step for the last one?
Divide.
Divide by everything we don't want. Everything besides dy over dx, right? Negative x times 2y minus 3y squared. Negative x 2y minus 3y squared. I run out of room.
This stuff's
Okay. So we get dy over dx equals y squared minus 1, which is difference of squares, but I'm not worried about changing that because it's not really pertinent to what we're doing. So I forgot to do this at the beginning, but I probably should. It's negative 1x times 2y.
Minus 2y.
There you go, yeah, negative 2xy. Is that necessary? No, but it's more likely you're going to see it that way. I would, yes, but for multiple choice, that answer wouldn't be there. They'd make you do that, yeah. Yeah, if you wrote that as an answer with the negative x times 2y, yeah, I would.
what is that going to
Absolutely, because it's the same thing. But yeah, for multiple choice problems, which these are a lot, tend to be a lot of multiple choice, common, very common multiple choice, that would be the answer there that they want. Okay. All right. All right, let's try number 3 now. My number 3 is way down there. Okay, so number 3. What the heck's going on? Okay, so number 3, negative 3xy, or sorry, negative 3y plus xy equals x cubed.
That's a whole lot of nothing.
Okay? All right, so try that one. I want you to try that one on your own. Okay. So negative 3, the derivative of negative 3y isn't negative 3y. I don't know why I put that. It should be negative 3, just negative 3. Yeah. Yeah.
Why did you put the dy over dx with the x and
I'll explain that right now. It's a great question. Why did I put that? So then I did that here, right? So this guy's here. This guy was here. So to do that, I had to use the quotient rule, right? Because these guys are multiplied together, or not the quotient, the product rule, right? So the product rule says the first, which is x, times the derivative of the second, right? What is the derivative of y? 1, right? But didn't I just find the derivative of y? So I needed a tag. And then it said plus the derivative of the first, right? The derivative of x is just 1. There is a 1 there. Times y. I didn't find the derivative of y that time. So because I didn't find the derivative of y, I didn't need a y, dy dx for that guy. Okay, good question. Very good questions. And then, so now what I'm going to do is I'm going to subtract y from both sides because that one doesn't have a dy over dx. So I get negative 3 plus x dy over dx equals 3x squared minus y. Divide by negative 3 plus x, divide by negative 3 plus x. That's supposed to be plus. Dy over dx equals 3x squared minus y. There we go. Okay. Here's my question. The first one, the first red one, matches our answer, right? Matches the answer I got. But last year I had a student, in my notes I wrote this down because I remember I wanted to talk about it. A student had that answer there. What's the difference between the two? What's the difference between the two boxes, two boxed answers?
Move the other ones.
So yeah, so what did they move? What did they move around?
Yeah, different terms.
Exactly. So those two answers are actually the same answer. They're actually the same answer. What's the difference? Well, all the signs are flipped, right? Positive 3x squared, negative 3x squared. Negative y, positive y. Negative 3, positive 3. Positive x, negative x, right? Here's the weird thing about math. One of the many. In math, if something is completely the opposite, it's actually the same thing. It's actually the same thing, okay? So if something is completely reversed, everything, all the signs have been changed, it's actually the same thing. I'll give you another example.
With negative 1 is the same as 1.
Not that. So that's a good example.
No, 1 minus 4.
Because isn't 1 really 1 over 1?
Oh, okay.
Isn't 1 really 1 over 1? So if I make a top negative and the bottom negative, isn't that really the same? Right? Think of a fraction, 1/3. If the opposite of 1 is negative 1, the opposite of 3 is negative 3, right? It's a double negative situation. It's the same idea here. Now, where would it come from? Just like you guys said, they swapped. They decided, you know what? I'm going to move dy dx's to the other side. Sometimes it's extra work, sometimes it's not. So what they did was they said, I'm going to move these guys over here, and I'm going to move this guy over here. Is that a reasonable way to do it? Yes. Is it the best way to do it? I wouldn't do it that way because, yeah, like you guys said, it's extra work. But sometimes, like even up here, no, that's a bad example. This one here. All right, we have two dy dx's, one on the other side. You usually want to go with the one that has the less work, right? So we moved this one over here and that one over there. But sometimes, on some problems we do, there will be one dy dx and one dy dx. And you're like, which one do I move? The answer is it doesn't matter. You're going to get the same answer. The thing about it, though, is that those will not be, only one of those will be on multiple choice. Only one of those will be on multiple choice. Which one, I can't tell you. I honestly don't know. It could be one, it could be the other. So just understand that they're both the same answer. Those guys are both the same answer. Could it be this one is one of the A, B, C, Ds? Yeah. Could it be that one is one of the A, B, C, Ds? Yeah. Right? It's the idea of if every sign is the same, it's the same answer. If every sign is different, it's still the same answer. Okay? I know it's a little confusing, but that's what it is. Okay? It's the way math works. That's why we have double negatives. It's where the double negative rule came from. Double negatives mean it's positive. Okay? All right, where's number 4? Way down there. All right, so let's do number 4 for sure, and then if we have time, we'll do another one, and then the rest are just examples. The rest are just examples that I wanted to show you guys. So it's not like there's anything else. It's mainly, today's just mainly practicing this, okay? Okay, so we got cosine. The angle is 2xy equals y. So again, we have two terms. It's always important to look at what we have in front of us. We have two terms. I have this guy here, and I have that guy there. So the 2xy is really one term. Here's my question. How do you find the derivative of that guy? Chain rule, and then inside that is going to be the product rule, yeah. It's the chain rule because we're going to find the derivative of cosine of something, right? And then we're going to chain on the derivative of the inside. Okay? So the first thing is, what's the derivative of cosine?
Minus sign.
Negative sign, everything else stays the same. Chain. Now we're going to find the derivative of the inside, right? It's 2x times y. So the chain says, the product rule says the first times the derivative of the second. Well, the derivative of y is 1 dy over dx plus. And then the opposite. The derivative of 2x is 2 times the second, which is y. Notice how I put those in brackets. The reason I put it in brackets is because that's the angle, right? So it's separate from this guy over here, okay? So it's not sine, negative sine of 2xy isn't just times 2x dy dx. It's actually times both of them, okay? So distributive property. And the derivative of y is just 1y. Just 1 dy over dx. So you can put the 1 in front. You don't have to put the 1 in front, but you can. It's already assumed. So now we got to get dy dx's by themselves. I have 1 inside, 1 on the other side. So to access this guy here, I'm actually going to have to distribute. To get rid of the brackets, I have to distribute here and distribute here. That'll get rid of the brackets altogether, and that's what I want. Right? Because if I divide both sides by negative sine of 2xy, that still wouldn't help me with the dy dx's. Okay? So we're going to go this times this. So we get negative 2x sine 2xy Okay. And then I'm going to distribute this with this guy over here. So it's going to be minus 2y times sine of 2xy. And then the other side remains unchanged because it's only dy, 1 dy dx. So now that those brackets are gone, I can now get dy dx by itself. Okay? So there's two terms that have dy dx. This guy and this guy. So here comes like what I was saying. Some students will move this over here. Some students will move this over here and this over here. Does it matter? No. I would suggest always doing the one with less work. So the one with less work, is there one with less work? I don't think there is. Because we definitely want to get these two guys on the same side. And I want to get this guy on the wrong side. Okay. So what I'm going to do, is this the only way? No. But this is what I'm going to do. I'm going to move this guy over here. And then I'm going to subtract dy over dx over here. So those guys will go away, and those guys will go away. So I'll have negative 2x times sine of 2xy dy over dx minus dy over dx okay. Factor out a dy dx, right? There is a 1 there. So if I factor out a dy over dx, that's going to be negative 2 times sine of 2xy minus 1 equals 2y sine. These types of problems are the hardest, by far the hardest, okay? So there's going to be nothing you see that'll be harder than this one. And it's mainly because of the distributive property problem. Distributive property, when you do distributive property, it just adds another layer to it. That's why I would consider these guys the hardest of the ones we're doing. Most of them are like the ones we've been doing. Like example 1, 2, and 3, most of them are just like that. I'll be right there. Yeah. Minus 1, negative 2, 2xy minus 1. That becomes 1. We get dy over dx equals this monstrosity.
How'd I read? I was like, this is a monstrosity.
It is.
At the same time, that's crazy. Yeah, the dokes.
Okay. Yeah, this is the last one we're going to do. So can I do this? No, why not? You guys are right. Good. Why not? Because of the minus 1. It's a binomial. This guy's a binomial. If the minus 1 wasn't there, it would have been a monomial, and you guys can cross your heart out. Okay? Can we do this?
Yes?
No.
We can never do that because it's angles. They're sine of that angle. So that one we can't ever do.
Sign of nuts.
It's not, exactly. It's not sine times 2xy, it's sine of 2xy.
Get it, sign of
Right?
nothing.
Yeah.
Not even 0, 1, sign of nothing.
Yeah, it would just be sine of what? Yeah. Okay? So yeah.
It was the whole side, no? Not 2x.
It's just like this, right? We can't go
But also
sine of x over cosine of x, right? We can't say cross out the x's, right?
Okay, what about the whole side?
If that was sine and that was sine, you could cross out the whole thing. And we could do that if it wasn't for that negative one. Yeah. Okay. All right. Good job, guys.